Hey everyone, in our previous session, we have discussed about logistic regression to solve classification problems in machine learning. However, there are some cases when logistic regression will not be competent enough to solve classification problems. In such situations, decision tree algorithm helps us to solve few of the classification problems in machine learning. Hence, along with logistic regression, we also should learn decision tree algorithm, which is a supervised learning algorithm, creates a tree-like structure, what you can see here, to predict the outcome. In logistic regression, we have seen that the algorithm uses sigmoid function to classify and predict the outcome. But in case of decision tree, it creates a tree-like structure to predict the outcome. It is very useful for both classification and regression problems. There are few important concepts what we should learn to understand how decision tree works internally to predict the outcome. Entropy, Gini's impurity, information gain, and pruning. These are the four concepts what we have to learn to understand how decision tree works internally. In our next slide, we will understand all these four concepts. Decision tree is very popular because of its simplicity. It requires very less data preparation. It can handle both numeric as well as categorical data. And furthermore, validating a model is very easy for decision tree. However, it suffers from overfitting problem. Apart from that, the structure of the tree is very unstable. Small change in data can lead to the huge change in the tree structure. Let's take an example and understand how decision tree works. Here I have a sample data set where we have outdoor temperature, humidity, airspeed, outlook and rain. This rain column has yes and no values. Yes means there is a high chance of rain. No means there will be no rain. We will be predicting rain based on these four independent variables. As you can see here, there are few independent variables which has categorical data and some independent variables can have numeric data too. Let's understand how decision tree creates a tree in order to take decisions. Let's take the outlook column first. If we split the outlook column, it will be splitted into cloudy, sunny and overcast. These are the three subcategories we have within outlook column. If we take only cloudy, there are 2 out of 3 cases when a cloudy day will have rain. 1 out of 3 cases, even though the outlook is cloudy, it will not rain. In case of sunny, if the day is sunny, then there is no chance of rain. And that is the reason if you see, total number of yes is 0 and total number of no is 2 in case of sunny. For overcast, there are a single case when it is raining, that is why yes will be 1 and no will be 2. Here it is no, here it is also no. Why we are splitting the columns? Decision tree splits the columns to evaluate precise decision. If you see here, if the outlook is sunny, then we can clearly tell that there will be no rain on that day. So from this small data set, decision tree has identified a single subcategory of an independent column such a way that if the value is sunny, then there will be no rain. This kind of split is known as pure split because from this split, the algorithm clearly take a decision based on the value. However, cloudy and overcast are not pure split because overcast category of outlook column is not indicating anything precisely. There could be rain or there may not be rain. Similarly, a cloudy day can be a rainy day or may not be a rainy day. This kind of splits are known as impure split. If there are impure splits, you have to take additional independent variables to get pure split. For example, here we have taken airspeed as well. If the airspeed is less than 5 kilometers per hour, there will be rain. That means that outlook is cloudy and airspeed is less than 5, then there will be rain. If outlook is cloudy and airspeed is more than 5 kilometers per hour, there will be no rain. If you see here, now we are getting pure split. Pure split means based on this condition, we can clearly take a decision. There will be a single category here. In this case, no rain category. In this case, rain category. This is option 1. However, decision tree can have a number of options to create the decision tree. It can take outlook as its root, or it can take airspeed as its root as well. If it is taking airspeed as its root, then initially you have 3 yes and 5 no's. If you see here, 1 yes, 2 yes and 3 yes. You have 3 yes and 5 no's. Still we have impurity, hence we are splitting it. How we are splitting it? Based on some condition. If the airspeed is less than 5, there will be 3 yes and 0 no. If the airspeed is greater than or equal to 5, there is 0 yes and 5 no's. So if you see here, with option 2, our decision tree quickly get pure splits. That means decision tree should choose the root feature or the column very intelligently, because last time in case of option 1, decision tree has put lot of effort to create the tree to decide if the day will be a rainy day or not. Whereas in case of option 2, only one single split gives us pure split. Hence, decision tree should identify the feature what will be chosen as root feature. Which feature to choose as root? Feature which has minimum impurity will be chosen as root. Now, in our case, as the example data set is very small and we can visualize all the data, we can count them up and understand that okay, airspeed is a better choice than outlook for the root feature. However, how computer will understand which feature to choose as root? To understand which feature has minimum impurity, we use something called information gain. Information gain is a numerical equation to decide which feature to select as decision node or a root node. Remember, outlook in this case is a root node, whereas airspeed is also a decision node, and the nodes which has pure split will be terminal node. Now, to calculate information gain, we need something called entropy or Gini impurity. Entropy is a measure of impurity in a given dataset. It measures how random your data is. Gini impurity also does the similar thing. It also measures the impurity of a given dataset. These entropy and Gini impurity are two different ways to measure the impurity in a given dataset. So, in our decision tree algorithm, either we can use entropy or we can use Gini impurity in order to calculate the information gain. Remember, Gini impurity is much faster and less expensive compared to entropy. However, the precision is more in case of entropy. Hope you have realized how our decision tree algorithm is choosing a specific feature as root. It is performing some calculation with the help of information gain equation. To calculate information gain, we have to calculate entropy or Gini impurity, because both measures the impurity in a given dataset. Now, in our case, as we have very small dataset, our tree size is not significantly high. But when you will be solving enterprise level problem statement, the size of this tree will be very huge, and because of that, decision tree suffers from overfitting. We will discuss what is overfitting and underfitting in our later session. For now, you understand, in order to limit the size of the tree, we use something called pruning. With the help of pruning, we reduce the size of the decision tree. In our practical example, we will see how pruning is enhancing the accuracy of decision tree. So now you know how decision tree is deciding which feature to choose as root node. There are a lot of mathematics behind information gain, entropy, Gini's impurity and pruning. In our next session, we will understand all the mathematics behind decision tree algorithm, because those mathematics will help you to understand decision trees internal way of working. We have SKLearn library which will give you a lot of inbuilt method. With the help of those methods, you can easily write code to utilize decision tree algorithm for your problem state. In order to use decision tree algorithm in your machine learning source code, you have to import decision tree in your file. From SKLearn import tree is the way using which you can import decision tree in your Python source code. Once you have imported the decision tree algorithm in your source code, you can create a model. Tree.decision tree classifier will give you the classification flavor of decision tree algorithm. After creating the model cannot perform predictions. You have to train the model with some training data. Fit is the method which takes training data as its input and train the model. You can use predict method which takes unknown independent variable to predict the class, because we are solving classification problem here. Model.score method takes test data as its input and provides us the accuracy of the model. With the help of this accuracy, we will decide whether we should use this model or we should retrain the model or we should search for some other classification model. Now it's time to write some Python code and implement decision tree algorithm with the help of SKLearn library. I have created a Jupyter notebook to explore decision tree algorithm. Let's understand the import statements first. Import pandas as PD used for data processing. I have a whole playlist on pandas. If you are not aware of pandas, you can go through it. I also imported Seaborn to use the sample data sets present in Seaborn library. This statement is to import the decision tree in our source code. From SKLearn import tree, with this statement we can import decision tree model in our source code. Matplotlib used for data visualization. We will be using Matplotlib here to display the decision tree at the end of the coding session. We have also imported train test split from SKLearn. This is used to split the whole dataset for model training and testing. So far in our previous sessions, we performed a manual splitting for training data and test data. In this session, we will also understand how we can utilize train test split method of SKLearn to split the whole dataset into training dataset and test dataset. Let's check out the data preparation part. Though the decision tree algorithm needs a minimal data preparation, we will see what we are doing as a part of data preparation here. Here we are creating a Titanic data frame with the help of Seaborn Titanic dataset. We are creating a subset of the dataset by selecting few of the columns. Let's see what dataset we will be using to explore decision tree algorithm. We have Titanic dataset where the survived column is the dependent column. 0 value in survived column means passenger did not survive. 1 means passenger survived. Apart from survived column, which will be our dependent variable in our machine learning code, these highlighted columns are the independent variable. P class means the passenger class, which ranges between 1 to 3, first, second and third class. We can get if the passenger is male or female, the age of the passenger, the price of the ticket passenger bought, and the passenger onboarded alone or with family. False means passenger onboarded with family. True means passenger onboarded alone. So in this session, based on independent variables, we will be predicting whether passenger survived or not. Hope you have understood the data set thoroughly. Now, as you can see, the sex column and the alone column does not have numeric values. In order to use them as independent variable in our machine learning model, we have to convert all these strings to numeric value. And that is the reason we will be using pandas library to replace male and female into zeros and ones and false and true into zeros and ones. And that is what we are doing here. We are creating a new dataset from the existing dataset, and then we are replacing female as 0, male as 1, false as 0, true as 1. Apart from that, in our dataset, we have few NaN values. We know how we can handle missing values. If you are not aware, I have the pandas tutorial series where you will get to know all the features and functionalities of pandas library. You can consult the same. I am using ffill here to handle the missing values in our dataset. Notice here, now our sex column and alone column has been converted into zeros and ones. With this, we are ready to use this dataset to train our decision tree model and test the same. Using train test split functionality of SKLearn library, we can pass the whole dataset. The first argument is nothing but the independent variables. Second argument is the dependent variable. With the help of test_size argument, we can decide how much data we want as training data and how much data we want as test data. 0.25 means 75% of the data will be for training the model and rest of 25% will be for testing the trained model. Sometimes if the data set has some pattern and we take the initial 75% for training and rest of the 25% for test, the model can be inaccurate. Hence, there is an option shuffle equal to true, which shuffles the whole data set first and then performs the splitting operation. Notice train test split will give you xtrain, xtest, ytrain and ytest. So while training the model, we will be using xtrain and ytrain. While testing the trained model, we will be using xtest and ytest. Hope you have understood how train test split method is helping us to split the whole data set into training data and test data. Decision tree classifier is a constructor we will be using to create the classifier flavor of decision tree model. Once we create the model, we have to train it with the help of model.fit method. It takes the training data. That's why I have put xtrain and ytrain. Once training is done, our decision tree model is ready to predict the unknown values. Let's first understand what is there within xtest. Xtest has all the independent variables for test data, and that is the reason we have p class, sex, age, fair and alone. You will not get survived column here because survived column is the column what we will be predicting with the help of the trained model. Model.predict will give us the survived column. Here 1 means the passenger survived, 0 means passenger did not survive. And here with the help of trained model, we are predicting the survived column for all the rows present in xtest dataset. To check the accuracy of the model, we will be using score method, which takes test data as its input. That's why I have used x_test and y_test here. Score method will give you a numeric value which is equal or less than 1. In this case, it is showing 0.74. That means 74% of the cases our trained model will give correct result. Now let's see how decision tree has been created internally by our decision tree model. As you can see here, we are getting a very big decision tree here. Sometimes this is the disadvantage of decision tree model. It is prone to overfitting. What is overfit and underfit in machine learning? For that, we will have a dedicated session where we will be discussing on overfitting and underfitting in detail. But for now, you note that overfitting and underfitting both are bad for a machine learning model. In order to solve overfitting problem of decision tree model, we use some technique called pruning. Pruning is a technique by which we can cut down the depth and reduce the overall decision tree. For pruning, we can pass a special option while creating the decision tree model called max_depth. Here, if you see the depth of this particular tree, what has been generated by our decision tree model has a depth of more or less 20. With the help of max_depth, we can limit the depth of the decision tree. Let's see how we can perform the same. In order to perform pruning, we have added max_depth equal to 3 here. This will limit the size of the decision tree. The maximum depth of the decision tree will be 3. Let's create the model again. Train the model. Now let's see with the pruning applied how we are solving the overfitting problem and the accuracy is getting increased for our decision tree model. Earlier it was 0.74. Now it is 0.81. That means more or less 80% of the time our model will predict the dependent variable correctly. Now if we plot the decision tree with the help of matplotlib, we can see the size of the decision tree is very less now. So with the help of pruning, we have reduced the size of the decision tree. On the other hand, we even increased the accuracy of the model because we solved the overfitting problem of our model with the help of pruning. If you see here, it is written Gini equal to 0.473. This is depicting that by default, when we will not pass anything to the decision tree classifier, it will be using Gini impurity equation in order to identify the root feature. It will be using Gini impurities to evaluate information gain and decide which feature to select as decision node or a root node. However, if we want entropy to be used as criterion, we can add the same while creating the decision tree classifier. By default, when we are not passing any criterion, it will be Gini impurity because Gini impurity is fast and cost effective measure of impurity in the given dataset. However, sometimes we use entropy because entropy gives better precision or accuracy. This time we will be using entropy as criterion and max depth equal to 3. Let's create the model again and check the accuracy. If you see now, the accuracy got further increased from 81% to 84% because this time we have used entropy instead of Gini impurity. Let's redraw the tree again with the help of matplotlib, and this time if you see, now entropy has been calculated instead of Gini. In our next session, we will see all the internal mathematics are being used by decision tree model to calculate information gain, entropy and Gini impurity. Note, while creating the model, we are passing some or the other options to make the model more accurate. This process known as hyperparameter tuning process, and this is very frequently used by all the machine learning engineers and data scientists. Let's summarize this session now. In this session, we have discussed about another machine learning algorithm called decision tree algorithm. It is part of supervised learning algorithm used for both classification and regression. In our session, we have only seen how we can use decision tree algorithm to solve classification problems of machine learning. We realized how entropy, Gini impurity and information gain is being calculated by the decision tree algorithm internally in order to find out the best decision tree. We have also experienced how pruning technique is helping us to solve the overfitting problem of decision tree algorithm. We realized what is pure split and what is impure split in decision tree, how information gain is helping decision tree algorithm to identify the appropriate feature as decision node or root node, how entropy is giving us more accurate results, whereas Gini is much faster and less expensive compared to Entropy. We have seen max_depth to limit the depth of the decision tree and enhance the model accuracy with the help of pruning. During our coding session, we realized how we can use SKLearn library to implement decision tree in our Python code without even knowing the internal mathematics of the model. However, in our next session, we will understand all the mathematics used for decision tree algorithm. Now we know how we can perform hyperparameter tuning to enhance the model accuracy. Hope you have enjoyed this session. Thanks a lot for watching this video.